Hello student, welcome to the 12th session of physics class. Myself Latha N, Assistant Professor of Physics, Government First Grade College, Sullia. Learning objective of this unit were already discussed in the previous sessions. Topics covered in this session are estimation of size of the nucleus, nuclear cross-section, differential cross-section, nuclear constituents, and nuclear size. First, we'll go to the estimation of size of the nucleus. From the Rutherford alpha scattering experiment using an alpha particle. So if we consider an alpha particle approaching the nucleus for an head-on collision at the distance of closest approach, we have kinetic energy of alpha particle is equal to the potential energy of the alpha particle. In the previous session, we have learned that at distance of closest approach, all the kinetic energy of alpha particle has been converted into potential energy of the alpha particle. Kinetic energy of alpha particle is given by half mv square, and the potential energy of alpha particle just we have discussed in the previous session, that is 1 over 4 pi epsilon naught 2 z e square divided by r naught, where r naught is the distance of closest approach of alpha particle, or this is also called as the radius of the nucleus. So maximum ಅಂದ್ರೆ ಎಲ್ಲಿ ತನಕ ರೀಚ್ ಆಗ್ಬೋದು, the end of the nucleus ತನಕ alpha particle reach ಆಗ್ಬೋದು. Let us consider the r naught value will be equal to the radius of the nucleus, and the distance of closest approach itself is equal to radius of nucleus. Then the radius of nucleus value can be estimated from that equation, that is r naught is equal to 1 over 4 pi epsilon naught 2 z e square divided by r naught. So cross multiplying this, mv square will be in denominator and 2 is the numerator. Therefore r naught will be equal to 1 over 4 pi epsilon naught 4 z e square divided by mv square. Next, coming to the nuclear cross section. The nuclear cross section is defined as probability that an event may occur when a single particle is shot perpendicularly at a target consisting of one particle unit area. Nuclear cross reaction ಅಂದ್ರೇನಂದ್ರೆ it is the probability, it may be chance. ಯಾವಾಗ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಸಿಂಗಲ್ ಪಾರ್ಟಿಕಲ್ ಅಂದ್ರೆ ಸಿಂಗಲ್ ಆಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ ಅದನ್ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ಹಿಟ್ ಮಾಡಿದಾಗ, ಏನಕ್ಕೆ ಹಿಟ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಟಾರ್ಗೆಟ್ ಏನಾಗಿರ್ಬೇಕು, ಇಟ್ ಶುಡ್ ಕಂಟೈನ್ ಒನ್ ಪಾರ್ಟಿಕಲ್ ಯೂನಿಟ್ ಏರಿಯಾ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಒಂದು ಬಾಲ್ ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳುವ, ಆ ಬಾಲು ಇನ್ನೊಂದು ಬಾಲಿಗೆ ಕರೆಕ್ಟ್ ಆಗಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ಹೋಗಿ ಹಿಟ್ ಮಾಡಬೇಕು. ಅದ್ರ ಪ್ರಾಬಬಿಲಿಟಿನ ನಾವೇನಂತ ಕರಿತೀವಿ, ನ್ಯೂಕ್ಲಿಯರ್ ಕ್ರಾಸ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. So nuclear cross reaction is the probability that an event may occur when a single particle shot perpendicularly at a target consisting of one particle unit area. And the total nuclear cross section is the effective area possessed by a nucleus for remaining of the incident particles from a collimated beam of all possible process. Total nuclear cross section is the effective area possessed by the nucleus for remaining incident particles. ಈಗ ಒಂದು ಡೈರೆಕ್ಟ್ ಆಗಿ ಒಂದು ಹಿಟ್ ಮಾಡ್ತಾ ಇದೆ ಅಂದಾಗ ಮಿಕ್ಕ ಪಾರ್ಟಿಕಲ್ಗೆ ಎಷ್ಟು ಏರಿಯಾ ಬಾಕಿ ಉಳಿದಿರುತ್ತೆ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಟೋಟಲ್ ನ್ಯೂಕ್ಲಿಯರ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. The total nuclear cross section is equal to total scattered cross section plus total reaction cross section, where sigma t is the total cross section, sigma s is the cross section that produces measurable scattering, and sigma r is the reaction cross section. So totally the sum of measurable scattering plus reaction cross section will be equal to total cross section. Next we'll move on to differential cross section. Cross section which defines the distribution of emitted particles with respect to the solid angle, that is called as differential cross section. ಅಂದ್ರೆ ಎಷ್ಟು ಪಾರ್ಟಿಕಲ್ಸ್ ಎಮಿಟ್ ಆಗ್ತಾ ಇದೆ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಂಗಲ್, ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಂಗಲ್ ಅಲ್ಲಿ ಎಷ್ಟು ಇನ್ಸಿಡೆಂಟ್ ಮಾಡ್ತಾ ಇದ್ದಾವೆ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಡಿಫರೆನ್ಷಿಯಲ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ದ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ವಿಚ್ ಡಿಫೈನ್ಸ್ ದ distribution of emitted particles with respect to a particular angle, that is called as differential cross section. The differential cross section per unit solid angle is defined as d sigma by d omega is equal to, as limit delta omega tends to 0, delta sigma by delta omega, where delta sigma is the solid angle and delta omega is the cross section. The nuclear cross section is depends upon the nature of interaction and the energy of the incident particle. Here the nuclear cross section depending on the nature of interaction and also the energy of the incident particle. Incident particle energy ಮೇಲೆ and also ನೇಚರ್ ಆಫ್ ಇಂಟ್ರಾಕ್ಷನ್ ಮೇಲೆ ಕೂಡ ನ್ಯೂಕ್ಲಿಯರ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ದ ಯೂನಿಟ್ ಫಾರ್ ನ್ಯೂಕ್ಲಿಯರ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಈಸ್, it is measured in terms of barn. Generally nuclear cross section is of a kind of area, it is of the dimension of area, and a particular unit is used to measure the nuclear cross section, that is barn. Therefore 1 barn is equal to 10 power minus 28 meter square, that is represented by 1b. So in problems we can substitute 1 barn as 10 power minus 28 meter square. So the area of the disk of single nucleus of medium weight is about 1 barn. Nucleus to area ಎಷ್ಟಿರ್ತದೆ ಅಂದ್ರೆ ಒಂದು ಏರಿಯಾ ಇರುತ್ತೆ, ಬಿಕಾಸ್ ದ ರೇಡಿಯಸ್ ಆಫ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಈಸ್ 10 ಪವರ್ ಮೈನಸ್ 14. ಸೊ ಡಯಾಮೀಟರ್ ತಗೊಳ್ಳೋದಾದ್ರೆ, ಏರಿಯಾ ತಗೊಳ್ಳೋದಾದ್ರೆ, ಸೊ ಇಟ್ ಈಸ್ ಆಫ್ ದ ಸೈಜ್ ಆಫ್ 1 ಬಾರ್. Next, nuclear constituents. From the Rutherford's experiment, we conclude that an atom consists of a very small region at center called as nucleus. Diameter of the nucleus is around 10 power minus 15 meter. The hydrogen nucleus is named as a proton. So first ನಾವು ಡಿಸ್ಕವರ್ ಮಾಡಿದ ಎಲೆಕ್ಟ್ರಾನು, ಆಮೇಲೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಡಿಸ್ಕವರ್ ಮಾಡಿದ್ವಿ. The nucleus of hydrogen contains 1 proton, ಹಾಗಾಗಿ ಅದನ್ನ ಪ್ರೋಟಾನ್ ಅಂತ ನೇಮ್ ಕೊಟ್ಟೋದು. Then after the discovery of neutron by Chadwick, it suggests that the nucleus is composed of both protons as well as neutrons. Neutrons ಡಿಸ್ಕವರ್ ಆದ್ಮೇಲೆ ಗೊತ್ತಾಯ್ತು ಏನಂತ, ನ್ಯೂಕ್ಲಿಯಸ್ ಒಳಗಡೆ ಚಾರ್ಜ್ಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಲೈಕ್ ಪ್ರೋಟಾನ್ಸ್ ಇರುತ್ತೆ ಅಂಡ್ ಚಾರ್ಜ್ಲೆಸ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಲೈಕ್ ನ್ಯೂಟ್ರಾನ್ಸ್ ಕೂಡ ಇರುತ್ತೆ ಅಂತ. ಪ್ರೋಟಾನ್ ಹ್ಯಾಸ್ ಎ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಆಫ್ ಸೇಮ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಸ್ ದಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ಪ್ರೋಟಾನ್ ಗೆ ಚಾರ್ಜ್ ಎಷ್ಟಿರುತ್ತೆ, ಸೇಮ್ ಆಸ್ ದಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅಷ್ಟೇ ಇರುತ್ತೆ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡು, ಬಟ್ ಚಾರ್ಜ್ ಮಾತ್ರ ಪಾಸಿಟಿವ್ ಇರುತ್ತೆ. ಅಂಡ್ neutron is electrically neutral and has nearly equal to that of proton. ಮಾಸು ಪ್ರೋಟಾನ್ ಅಷ್ಟೇ ಇರುತ್ತೆ ಬಟ್ ಚಾರ್ಜ್ಲೆಸ್ ಪಾರ್ಟಿಕಲ್. ಆಲ್ಸೋ electrons protons and neutrons are called as building blocks of matter, and the, these three are called as fundamental particles ಅಂತ ಕರಿತೀವಿ. The fundamental particles are electrons, protons and neutrons. These are the building blocks of matter and also called as fundamental particles. Next, the protons and neutrons together we can call as nucleons, because both protons and neutrons are inside the nucleus. That's why they are called as nucleons. The number of protons in an atom is called as atomic number. The number of protons present in the atomic nucleus is called as atomic number, and it is represented by the letter Z. So, an atom is electrically neutral and the number of electrons orbiting the nucleus is equal to number of protons. ನಮಗೆ ಗೊತ್ತಿದೆ ಆಟಮ್ ಯೂಶಲಿ ನ್ಯೂಟ್ರಲ್ ಆಗಿರ್ತದೆ. ನ್ಯೂಟ್ರಲ್ ಆಗಿರ್ಬೇಕಂದ್ರೆ ಎಷ್ಟು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇರುತ್ತೋ ಅಷ್ಟೇ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇರಬೇಕು. ಹಾಗಾಗಿ ದ ನಂಬರ್ ಆಫ್ ಪ್ರೋಟಾನ್ಸ್ ಈಸ್ ಸೇಮ್ ಆಸ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಜಡ್ದೇನಿರುತ್ತೆ ನಂಬರು ಅಷ್ಟೇ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. The total number of protons and neutrons in the nuclei is called atomic mass. Protons ಮತ್ತೆ neutrons sum ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಅಟೋಮಿಕ್ ಮಾಸ್ ಅಂತ ಕರಿತೀವಿ ಅಥವಾ ಮಾಸ್ ನಂಬರ್ ಅಂತ ಕರಿತೀವಿ. That is represented by the letter capital A. The number of neutrons in the nucleus is A minus Z. That means if we subtract the number of protons from the atomic mass, we'll get the number of neutrons. In general, a nucleide is represented by the symbol ZXA, where X is the chemical symbol of the element. We know that from the periodic table, different elements contain different chemical symbol. For example, we can take chlorine atom. Chlorine atom can be represented as 17Cl35. Here Z is the atomic number, A is the atomic mass. The number of protons is equal to number of electrons, that is equal to 17 irutte. And the number of neutrons will be equal to A minus Z, that is 35 minus 17 is equal to 18. Then coming to the size of the nucleus, from the Rutherford experiment, it was found that the mean radius of an atomic nucleus is of the order of 10 power minus 14 to 10 power minus 15 meter. So, size of the nucleus is 10 power minus 14 to 10 power minus 15, and the atomic radius is having the dimensions of 10 power minus 10. ನ್ಯೂಕ್ಲಿಯಸ್ ರೇಡಿಯಸ್ಸು 10 ಪವರ್ ಮೈನಸ್ 15 ಇರುತ್ತೆ, ಅಂಡ್ ಆಟಮ್ ರೇಡಿಯಸ್ ಎಷ್ಟಿರುತ್ತೆ, 10 ಪವರ್ ಮೈನಸ್ 10 ಇರುತ್ತೆ. ದಟ್ ಈಸ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಈಸ್ ಅಬೌಟ್ 10,000 times smaller than the radius of the atom. ಆಟಮ್ಗೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಅದರ ನ್ಯೂಕ್ಲಿಯಸ್ ಎಷ್ಟಿರುತ್ತೆ, 10,000 times ಚಿಕ್ಕದಾಗಿರುತ್ತೆ. ಸೊ from other scattering experiment using high energy protons, electrons and neutrons, it shows that the nucleus is spherical in shape with certain radius r. So ಏನು ಗೊತ್ತಾಗುತ್ತೆ ಅಂದರೆ, ತುಂಬ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಕಂಡಕ್ಟ್ ಮಾಡಿ ಸೆಂಟ್ರಲಿ ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜ್ಡ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಇರ್ತದೆ, and that nucleus is in the shape of sphere with certain radius r. ಹಾಗಾದ್ರೆ ಅದ್ರ ರೇಡಿಯಸ್ ಎಷ್ಟಿರುತ್ತೆ ಅಂದ್ರೆ, ಎಂಪೆರಿಕಲ್ ಫಾರ್ಮುಲಾ ಫಾರ್ ದ ನ್ಯೂಕ್ಲಿಯರ್ ರೇಡಿಯಸ್ r is equal to r0 a power 1/3, where a is the mass number, r0 is a constant, that is 1.3 into 10 power minus 15 meter, represented by Fm. Therefore, r0 is equal to 1.3 Fm. The nuclear dimensions are measured in terms of femtometers. 1 femtometer is equal to 10 power minus 15 meters. Femtometers is represented by Fm. The references for this session are listed. Thank you.